Okay, so we're going to learn to go from a gram to one substance to a gram of another substance. Um, why this is important is because in lab all the time, or in chemistry, or really anything you're doing, you might want to know how much product you're making. Okay, so let's say we put so many grams of reactant in. So how much product would that produce? You know, it's really important in industry or in a lot of things, really. So this is how we do it. Let me show you. First of all, let me show you the one conversion before we do that. And that is a gram to a molecule. I just want to show you that that's the same as going to a atom. So if we have 10.8 grams of CO2 and we want to go to molecules, this is the same as going to a atom because it's always molecules slash atoms. So the first thing we're going to do is we'll have our grams of a substance, and we'll go from a gram to a mole, and then from a mole to a molecule or an atom, depending on which one we're going to, it doesn't matter. Okay, so it's set up exactly the same. So let's look at this. We have 10 grams of our substance of CO2, and anytime you have a gram mole or a mole gram, anytime moles and grams are on top of each other in some way, that is your molecular weight. Okay, and we want to know of CO2. So we have a C and we have an O. We have one carbon, that weighs 12, and we have 2 oxygen, which weighs 16. And this just comes from because we have one carbon, 2 oxygens, and on the periodic table they weigh 12 and 16. When we add these together, we're going to get 44 grams per 1 mole, which is the conversion we need right here. So there are 44 grams of CO2 per 1 mole. Now the conversion for moles and molecules, remember for 1 mole, there are 6.022 times 10 to the 23rd molecules. So if we multiply this out, okay, we're going to go 10 times 6.022 times 10 to the 23rd and divide that by 44 grams of CO2, and we get 1.48 times 10 to the 23rd molecules. So you see there's the same conversion we've been doing to go to atoms, except now we're going to call it molecules because we're not looking at an individual atom, we're not looking at just carbon, we're looking at CO2, which is a molecule. So we're just calling it something else, but the conversion is the same. Okay? Now let's looking at going from a gram to a gram. You pull up the PowerPoint here, and we're going to learn a new conversion, and it's called a mole-to-mole ratio. We've gone from a gram to a mole. That's just using molecular weight like we've done before. But usually we go from gram to mole to either atoms or molecules. But now we're going to go all the way to grams. So this new conversion we need to know here is called a mole-to-mole ratio, it's actually a pretty simple conversion. So we're going to go from a gram to a mole. Anytime you're going from a gram to a mole or a mole to a gram, you use molecular weight. Mole to mole is a ratio, and mole to gram, again, is molecular weight. Okay, so let's look at an example. And first, before we do a whole long example, let's do a short one. Let's just do a mole to a mole. So we're going to go from moles of A to moles of B. So we have 38.5 moles of CCl2F2 per chlorine mole. Okay, let's see what that looks like. So we have 38.5 moles of CCl2F2, and then we want to know how many chlorine moles are in that. Okay, so let's look at the mole-to-mole ratio. All right, or let's start doing the shell. So we're going to go from moles of A, I'm going to call this A, this B, we need to get rid of moles of A, and remember to do this, we do the mole ratio. We go to moles to B. Okay? Now this is new, so you haven't seen this before, so you've never seen a moles of A to moles of B. So let's see how we get this. Let's start off here with the number we do have, which is 38.5 moles of A. Now we need to do this mole ratio. What is that? Okay, well this says for every 1 mole of this, how many moles of chlorine? So how many chlorines are in there? 2. So every 1 mole of A, so every 1 molecule of A if you want, how many chlorine atoms are in there? 2. So let's say we're looking at fluorine, what would we see? So for every 1 of this whole entire molecule, there are 2 fluorines. See right there, it says 2. What about carbon? If we're looking at carbon, so for every 1 of these, there's 1 carbon. So that would be a 1-to-1 ratio. So when we multiply this out, we get 77 moles of chlorine. Okay, so that's how you do a mole-to-mole conversion there. Now let's go all the way to grams to mole, because this is the harder one. Okay, this says 25 grams, and we're going to go to grams of chlorine. Okay, so let's write out what we're doing here. We're going to go, 25 grams of CCl2F2. We want to know grams of chlorine. Okay? Here is the shell we will always use to go from a gram to gram. We're always going to go grams of A. We're going to do, we need to get rid of grams of A, so put grams of A down here to moles of A. You always have to convert grams to moles. You'll find that in chemistry a lot. Then we're going to go, this is our new conversion, mole of A to mole of B. And then mole of B to gram of B. Now let's look at this. Here's a mole-gram ratio, so this is just molecular weight. Here's a mole of A, mole of B, so that's our new one called the ratio, a mole ratio. And this here, gram-mole ratio, that is again just molecular weight. Okay, so let's look at this. let's just start doing this. Let me change the color. We have 25 grams of A, because I'm going to say this is A, this is B. Okay, now we need to know the molecular weight of A. So we have a C, we have a chlorine, we have a fluorine. Carbon, there's only one of them. It weighs 12. Chlorine is 35.45. And there are 2 of those. And then fluorine, there's 19. This is all from the periodic table. There's 2. How do I know there's 2? Because it says there's 2. 2 and 1. So when we multiply and add these all together, we're going to get about 120 grams per mole. I'm rounding here. I think it was 120.9, but let's just say 120 to make it simple. So here, we're going to have 120 per 1 mole. Now what's the mole-to-mole ratio of A to B? So for A, for every 1 of these, how many B's are there? So we're looking at chlorine. 2, given right there. Okay, so 1 mole of A, 2 moles of B. Now look here, this is just a molecular weight of B. So how much does chlorine weigh? 35 on the periodic table. So chlorine, 35.45 actually, per 1 mole. And let me show you on the periodic table. Right here, see chlorine, 35.45. That's the number I'm getting from. Okay, now let's just multiply everything all out. When we do 25 multiplied by 2, multiplied by 35.45, and let's divide that by 120, you should get about 14.7 grams of chlorine. Okay? So I know this sounds, hard and confusing, and But just remember, it's the same thing every time. Let's do one more example to really drive this in. Now this one I'm just making up in my head. Okay, so this time let's say we have 10 grams of CCl2F2, and let's remember that this weighs 120 grams per mole. Okay, and we want to know how many grams of carbon there are in that. And from the periodic table, this is 12 grams per mole. Okay, so let's write down our shell. Grams of A, we're the same thing as we did before. This is going to go grams of A, moles of A. Remember, this is just the molecular weight. Our next step, remember, is the mole ratio. Mole A here, mole B right here, and then one more. We're going to have mole B to gram B. Right, this is the molecular weight of B. This is the ratio. Now let's fill in our numbers, and we cut it in a new color again. Use pink. Okay, so let's start out. How many grams of A? Oh, and let's classify, make sure we realize. So we're starting with A, and we're trying to find out B. You're always trying to find out B. Okay, so we start off with 10, as given right here. Now let's look at here. We need the molecular weight, grams per mole, and we wrote that right here. It's 120. 120 gram per 1 mole of A. Okay, now let's go to the mole-to-mole ratio. So we're looking at 1 mole of A. So 1 mole of A. And how many moles of B? Carbon moles are in A. There is 1. So every mole of A, there is only 1 carbon found in there. So that'd be a 1-to-1 ratio. And our last step here, we need the molecular weight, grams per mole of B, which is our carbon, which we said here was 12. So 12 grams per 1 mole. So let's multiply this all out. We have 10 times 12 divided by 120. That's going to be approximately 1 gram of carbon. So in 10 grams of this molecule here, by mass, 1 gram of that is carbon. So again, hopefully seeing that it's just the same thing over and over again. Okay, we're going to use this shell here. Now let me show you. Let's say the problem gives you moles of A and wants you to go to grams of B. You know, instead of going from a gram to gram, they want you to actually start from a mole. Well, that's fine. Then you just leave out this part right here. Why both of those? Because it's grams of A. We don't need grams of A. We're just starting with moles of A. So our shell then would become mole A, mole B, mole A, gram B, mole B. Just like we did up here. Okay, so let's say they want us to go from a mole of A to a mole of B. How do we do that? We set it up. Actually, let me cancel this. Let me just delete all of this and just show you. Okay, so if we're going from mole A to mole B, then you start with mole of A. You want to cancel out moles of A, and you want to go to a mole of B. So you see, it's just this part right here, okay? You know, and let's say, well, they actually want us to go to grams of B. Okay, we'll just add that. Add the next part, mole of B, grams of B. So you could start and end at any point here. But this is just, if they ask you to go the longest way here, so gram to gram, this is how you do it. Okay? So practice that and let me know if you need any help. Our next one, we're going to go over percent conversion, just a simple version of that, and make sure you can do that.